Yes, you are welcome to my next tutorial on understanding algorithm. The objective of this tutorial series is to help people out there to be able to understand uh, some of the difficult part of an algorithm and text materials like this, especially those areas that I myself I had a hard time understanding them. uh, and I believe there may be people like myself out there who also is having a hard time understanding uh, such materials like this. The last time we discussed the problem of top-down approach, and we mentioned that we can reduce a high-level problem like the simple select into merely a sorting problem. In other words, if we are able to just achieve the sorting problem, then returning the element in the position of k in array A is a simple work. It's as if you're doing nothing. So now here we now have reduced the problem to sorting the array. And how do we sort the array? In order to sort the array, we also use the same concept of reduction to reduce the problem of sorting into smaller instance of sorting. And that is what is being explained in this place, if we take time to go through it. The summary of it is, if we have to sort, so we have carved out the sort part of it. So if we have to sort, we can use one of the variant of sort, which is insertion sort, and we're taking the array. Now we reduce again the insertion sort into sorting a smaller instance of the original array. And what does that mean? If the original array contains 0 element, does not have any element, then there's no work to do. If the original array has just one element, there's no work to do. So I want us to understand the flow of things here in this place. This insertion sort, the whole of this code that we have here, it represents what we have in this place, this line, just this line. So you can take those codes and just plug it in here. Don't forget, at the end of the day, you are still going to return a of k. That is very, very important to be able to grasp this material. So now we are now back to the problem of how do we sort. We see that if we have less than one element, then we don't have to do any work. We just return a of k, believing that the k that will be supplied according to the specification of k in our earlier specification, we mentioned that the k will always be less than or equals to 1 if you look at the specification of the specification of our algorithm. I just want to quickly go back to show us and to make us to know how important the specification is. We are sure that our k will satisfy this property, that is, k will be less than or equals to n. So we're sure that whatever value that k is given will be within the range of the number of elements that we have in the array. Okay, just to make sure that we are following along. And that is the reason why we have specification. Specification gives us a safe environment to be able to work, because we know that certain conditions are already met, so we don't have to care about met conditions. So if n is greater than 1, that is the number of elements in our array is greater than 1, then we reduce the original array, sorting of the original array, into sorting of one less of the original array. So this is what we refer to as recursion, recursive call. You will see that we are calling back the insertion sort. So we're calling it back within its own execution body. So this is what is referred to as recursion. And it is worthy of note here that you will see that we are calling back this insertion sort on a smaller instance. So if the original array has 2 elements, the insert sort here will be called on just 1 element. If the original array has 10 elements, this will be called on 9 elements. So it's important that when you do a recursive call, you must continue to continuously reduce the problem until it reaches the base. And when does it reach the base? It reaches the base condition when n is equals to 1 or less than 1. That is when the recursion will terminate. Right. And so we move on again, and we have insert a 1 to n. Now this insert, what essentially this is doing is to help us to be able to check the ordering, which is also referred to as permutation, the ordering of our arrays. And this line, this single line of insert, is expanded in this place. That is what is referred to as recursive insert, and that is where we're going to continue in the next tutorial. I believe this will have helped somebody out there. Kindly give us a thumb up if you have benefited, and if you have not, you can also give us a thumb down. All this will help us to be able to improve in subsequent ones. Thank you for listening.